The group manages orphanages, schools, mobile clinics, soup kitchens, dispensaries, programs for children and families, and counseling services. Numerous awards such as 1962 Raman Magsaysay Peace Prize, the 1979 Nobel Peace Prize were awarded to Mother Teresa. She also won Jawaharlal Nehru Award for International Understanding and the Padma Shri from the Indian government. She has been awarded Bharat Ratna in 1980. This was a concise overview of Mother Teresa, and today we will be dedicating this session to her. And with that, let me officially introduce Dr. Chandrama Chakraborty ma'am, who will serve as this FDP session's resource person. Dr. Chandrama Chakraborty ma'am is currently serving as an assistant professor in the Department of Economics, Vidyasagar University in West Bengal, India. Dr. Chakraborty did her post-graduation in economics from University of Calcutta, India, and then she obtained her MPhil and PhD degrees in economics from Jadavpur University, India. Her major areas of academic interest include applied econometrics, industrial growth and productivity and efficiency. She is also interested in environmental economics, gender issues, agricultural economics, as well as health and economics of education. She has several publications in both national and international journals, as well as in edited books of reputation. She has also published a number of books as editor. She, as a principal investigator, has also completed a few research projects funded by UGC and ICSSR. Today, our session will be on the problems of endogeneity, GMM, and system GMM models using eViews or STATA. So without further ado, I welcome ma'am to the first session of the day and express my hope that it will be a fantastic learning opportunity for all of us. Please proceed, ma'am. Thank you.
Thank you, Fatima Zohra.
Madam, I welcome you again to the session.
Okay, thank you. Thank you so much. Okay, so shall I start? Shall I share my screen?
Yes,
okay,
yes,
thank you. Is the screen visible?
Well, perfect, madam.
Okay.
Yes, ma'am.
Okay, so today I am going to discuss on problem of endogeneity, method of moments, and general method of moments. Okay. So first we will start with some basic concept. So with some examples, I think we can be able to understand endogeneity problem very clearly. So first example is regarding an ice cream vendor. Okay, so we all are very much a lover of ice cream, I think, isn't it all? We all enjoy ice cream, eating ice cream, especially in hot season and in cold season as well. We also enjoy ice cream. So this is a very common real life example. So to start with, I would like to start with this ice cream vendor example to understand the concept of endogeneity. Now, the problem is an ice cream vendor sells ice cream on a beach. Okay, so he collects data for total sales and selling price of ice cream for 2 years. He gives the data to a data scientist, asking him to find out the optimal selling price of ice cream. Okay, so have you got the point that the vendor has collected data for 2 years on two variables. One is the total sale of ice cream, another is the selling price of ice cream. And he gave the data because he don't know econometrics. So that's why he gave the data to a data scientist for finding out the optimal selling price. That is, what is the best selling price that the ice cream vendor can use for further selling of his ice cream. Now the data scientist, he knows econometrics and he has run a linear regression model. That is, you all are very much habituated with this linear 2-variable linear regression model. Y is equal to alpha plus beta x plus some error term, so u. And by finding out the finding out the profit function, you know that profit function is nothing, profit is nothing but the difference between revenue and cost, isn't it? So the profit function based on this selling supply equation, or this selling equation, is x minus cost into alpha plus beta x. That means x into y minus cost into y. Okay, so that is, if you take alpha plus y, that is, if you take y common, then you will be having x minus cost, and if you replace y by alpha plus beta x, then after, you know that after running the regression, error term vanishes. That means the average of the error term is 0. Summation ui hat is 0, so you can have yi hat, which is equal to alpha hat plus beta hat x. So the profit function is x minus cost into alpha plus beta x. So all are known, that x data is known, cost data is also known, alpha hat, beta hat after estimation is known, and the profit amount can be easily found out. And by differentiating the profit function with respect to x, the data scientist can find out the optimal selling price. Okay, so the optimal selling price can be obtained based on this linear regression model. But the vendor has made a mistake. The interesting part is that the vendor has made a mistake. The vendor has not said to the data scientist about his actual pricing strategy. Okay, what the vendor does, the vendor actually he increases the price of the ice cream once the demand was high. If the vendor found that the demand for the ice cream is very high, then what the vendor charges higher price. So he has mistakenly forgot, or he has done a mistake. He has forgot to mention his price strategy to the data scientist. Okay, so without knowing the price strategy, that the vendor charges higher price when the demand rises, the data scientist has run the regression and he has found the optimal price. So the linear regression is that selling price increases and the sale increases, or the slope is not as negative as expected, isn't it? So what is the result? What is the outcome? That the optimal selling price is not at all suboptimal, or rather the selling price which the data scientist has found out is not at all optimal, isn't it? Because without knowing the selling strategy, the data scientist cannot find out the optimal price. So this is example 1. We are coming to the endogeneity problem. Where is the endogeneity lies, that we will discuss. Let's think about the examples first. So this is the first example. The second example is a merchandise store. Actually, so let me use the okay. Now for example 2, this is coming. Okay. For example 2, is it visible? The screen is visible?
Yes, ma'am, it's visible, ma'am.
Okay, thank you. Okay. For example 2, the example 2 is regarding a merchandise store. Okay. So a merchandise store gives customized coupon to its customers. There are different coupons with different, you know that we all are aware of the coupons, isn't it? We are very fond of having some offers. Okay, some buy one get one, or some gifts are there. So different types of offers are there along with the coupon. Okay. isn't it? So the same is the example to here, that a merchandise store gives customized coupons to its customers. The store collects data for customers' response. That is, they use the coupon on whether the customers are using the coupon or not, and also the coupon details. That means what type of coupon has been given to that customer. So two types of data are being collected. One is the coupon details, that is what type of coupon it is. This is X, and whether the customers are using the coupon or not, that is Y. Okay, they want to know the effectiveness of each coupon. Okay, so that they could customize it and send it to different customers in future. So obviously the store is very much interested to know the effectiveness of coupon. That is, if the coupons are given, the customers are buying more or less, or whether the customers are interested without coupon. So all these things are very much interesting for the merchandise store. So again, the merchandise store has given the data to the data scientists to fit the model. Okay, but the merchandise store has forgot to say something. That means some information is missing. What information? That is, the store had a particular strategy to give the coupon. That means, what is the strategy? That the store gives coupon if it's not a randomized coupon. Okay, the store is using some strategy to give coupon. If the store finds that a customer will buy even without a coupon, they will not give any coupon to that particular customer. The store will think that the customer is very much interested, or is interested in purchasing from this store. So the customer don't want any coupon. So they don't waste any coupon for that particular customer who is very much interested in purchasing purchasing goods or some things from the store. But if the store thinks that a customer may buy or may not buy, then they give coupon to that particular customer. Okay, so this strategy is not disclosed to the data scientist. So again, you are seeing that whatever result is being obtained without knowing the particular strategy of the store, that will not give the optimal solution, isn't it? The third example we are talking about is the movie artist with awards. You know that movie artists are very hard workers. Obviously, they should work hard to win awards. Movie artists, they have to have awards after they do some hard work. Okay, the producers, the film producers, they want to affiliate themselves with artists who have won awards as their affiliate award with acting quality. Hence, they get better opportunities, and thus they reap more recognition and more awards. That means the reach becomes richer. The movie, have you got the example 3? That is, the movie artists, they work hard for getting awards, and the producers are very much interested to take those artists who have won awards. So what is happening is that those artists who are winning awards, they are getting better opportunities, and thus they are getting more recognition and more awards. That means the award winners are again getting awards. So this is a very common phenomenon, you know. So we can call it that reach becomes richer. Okay. So in all the 3 examples, you can see that there is some missing information. In the first example, the ice cream vendor forgot to tell about the pricing strategy. In the second example, the merchandise stores forgot to tell about the strategy of giving coupon. And in the third example, you know that the example 3, we are seeing that the movie artists who are winning award, they are again getting chance, but the other artists who have capability, but they are not getting awards, they are not getting chance. Okay, so here in this example, Now, all these examples, in terms of econometrics, all these examples violate one of the fundamental assumptions, that is randomization. You know that in econometrics, we consider the X variables or the explanatory variables to be non-stochastic, that is non-random, isn't it? So we should randomly set the value of the independent variables and observe dependent variables, right? We consider X to be non-stochastic. That means we should consider some specific values of X, which is very much random in nature. Some specific, suppose if you're interested with income, monthly income, then X may be 10,000, 20,000, 30,000, 40,000, and so on. So there should be some randomly selected values. But in all the three examples, you can see that there is no randomization. All are actually being done purposively, isn't it? For the first case, the vendors, the ice cream vendors are using the strategy. They are using the demand strategy. If the demand is high, the ice cream vendor charges higher price. For the second example, if the coupon is, if the merchandise store finds the customer to buy more, they will not give coupon. But if the merchandise store is not convinced about the purchasing by the customer, then they only give the coupon. And for the third case, also there is a strategy that those artists who are getting awards, they are only getting chance. But those artists who are not getting awards, they are not getting chance by some producers. So all are using this, the ice cream vendor or the merchandise store or the producer, movie producer, they are all using some strategy. There is no randomization. In other words, the independent predictor variable, that is X, should be exogenous. We know that in the econometrics or using ordinary least square method, the variable X should be exogenous and not endogenous. But here we see that these variables are not being chosen randomly. These variables are chosen by using some strategy. So exogenous variables are not driven by other factors, observable or unobservable. But here you can see that the explanatory variable X is being driven by some strategy or by some factors, whether observable or unobservable. The first example, let me come to the examples, all the three examples. In the first example, the price was driven by temperature. That means if the demand is high, the price is being charged high. The second example, coupons were driven by past sales. If the customer is purchasing, then he will not get coupon. But if the customer may or may not purchase, then he is given coupon. So by the past behavior of the customer, coupons are being given. The third example also, you can see that the movie producer is taking those artists, is giving chance to those artists who are winning awards. Okay, so endogenous variables are correlated with the error terms. This is the most important line with which we will be dealing with in this session. So we will come to that very shortly. But before that, are you clear with those three examples? Please respond.
Yes, ma'am.
Yes, ma'am.
Okay. So these three examples, I think, is very much interesting. No? It's very close to our real life situation, isn't it? We all are very much aware of this situation. So the response variable Y should be explained by some independent variables X. Okay, and that could not be explained by X is included in the error term. You know that if the model is Y is equal to alpha plus beta X plus U, X should explain Y. And if there are other causes or other factors which are explaining why, that is incorporated in the error term. You know the essence of error term or the usefulness of error term. That means the excluded causes, the causes which we have not excluded, we have not included in our model, that is the excluded causes are incorporated in the error term. The error term captures the excluded causes, isn't it? So we know that if there is some collinearity, if there is some association between the explanatory variables, that is the case of multicollinearity. There's X1 is explained by X2. So we in the linear regression model or for applying OLS, we don't need this type of, we don't want this type of problem. You know that if this type of problem arises, then the OLS the OLS estimators are not blue, best linear unbiased estimator, isn't it? So we don't want any multicollinearity, that means association between the explanatory variables, or we don't want the error term to be correlated, we don't want the error term to be correlated with the explanatory variables, that is X. Okay. But sometimes it happens. That is, if there is a factor Z and it is included in the error term, it can explain Y. But Y is the independent variable. Okay. But if Z could explain any of X, that means in the first example, Z is say temperature, Z is temperature, and X is the price. And you can see that in the first example, temperature affects price, isn't it? So the error term is correlated with X, yet Z is not incorporated in the model. Can you remember the two-variable model? Y is equal to, the data scientist has run a two-variable regression model, Y is equal to alpha plus beta X plus UI. So there is no Z in the model. But Z is some omitted variable in the model, and say Z is a temperature. Now temperature affects price. So you can see that the Z, which is not incorporated in the model, it is incorporated in the error term. So X and U are correlated. That means there is some association between the error term and X, the explanatory variable. So you know that this is very much alarming, isn't it? The OLS estimators fail. OLS estimation fails to give the best linear unbiased estimator. Okay. So the issue of endogeneity arises when we have a Z that is related to Y, but is also related to X and not included in the model. That means the Z, that is the factor, may be observed or it may be unobserved, and that is related with Y, and it's also the most worst part is that it is also related with X. That means there is some association between the unobserved variable and the exogenous variable X in the model. Okay. So there is a very wide range of sources of endogeneity. We have considered, for the example one, we have considered temperature to be the unobserved variable. Temperature to be the variable which is correlated with X, that is the price. The vendor may use other strategies as well. Vendor may changes location based on time, or what if the vendor changes price based on the queue? If the queue is more, the vendor may charge higher price. Or if the vendor may be selling the ice cream in some posh area, then he may be charging higher price. That is also a strategy. That these are also different Zs, isn't it? Which are not included in the model and is incorporated in the error term, but is actually affecting the price, selling price of the ice cream. That means this Z, it may be temperature, or it may be the location, or it may be the queue. Okay, so whatever it is, the thing is that we are concerned with the we should notice, or we are concerned with the thing that this Z is correlated with the explanatory variable X in the model. Okay, so this Z, which is included in the error term, is correlated with the is affecting or correlated with the explanatory variable. But you know that one of the basic assumption of ordinary least square method is that covariance of XU equal to 0. That is, there should be no correlation or association between the explanatory variable and the error term. But here in this type of real life example, these are very much frequent, isn't it? We see these things in our real life, that this endogeneity problem actually arises. That is, we found that this type of strategies are being taken by the vendors, this type of strategies being taken by the merchandise stores, or in the example 3 about the movie producer, and hence some error term, or rather some variable which is associated with the error term is associated with the explanatory variable. So the basic assumption of the ordinary least square method, that is covariance of x2 equal to 0, gets violated. Okay. So I think that you have learned a little bit. Maybe you are brushing up. Someone knows about it very well, or maybe someone is a fresher for this type. I don't know, but I think that you have brushed up. Those who know it already, they have brushed up, and those who are new to this idea, they have learned a little bit about endogeneity. Is it clear about the endogeneity concept of endogeneity? That is there is some association between the error term and the exogenous variable. Okay, so I have tried to relate those association between the explanatory variable and the error term with the help of three real life example so that it becomes much clear to you. Okay. Now, so is it clear to you, or do you have any question right now? No, I think
It's clear, ma'am.
no question. Is it clear?
Yes, ma'am.
Okay, thank you. Now we are coming to the sources of endogeneity. There are basically three important sources. We can broadly categorize the different sources of endogeneity into omitted variables, simultaneity, and selection bias. Okay, so first is omitted variable. As you have seen in example 1, that is the ice cream vendor has forgot to tell about the temperature, and temperature is the omitted variable. Okay, so due to the missing observation, about the strategy of the ice cream vendor, the result is not at all optimal. The second example is the second reason or the second factor for endogeneity which causes endogeneity is simultaneity. This is very, very important, and this is quite often. All are important, all the three are very much important, but you know that simultaneity exists everywhere. Simultaneity, you can see simultaneity in example 2, where X causes Y and Y causes X. That means the sale of or rather the coupon, giving coupon is dependent on sales, and sales are dependent on coupon. Isn't it? A merchandise store gives coupon to those customers who may or may not purchase. That means giving coupon is dependent on sale. And also, if there is more sale, the merchandise store will not give coupon. But if there is any difference in sale, that means if the customer may or may not buy it, then he will get coupon. That means coupon, depending on coupon, the customer may buy, and depending on the customer, the store is giving coupon, isn't it? So if I am a customer who may or may not purchase, the store will give me coupon, isn't it? And and if I have a coupon, I am interested in purchasing. So there is a both way causality from X to Y as well as Y to X. So this is the most common and also the difficult situation. So example 2 is an example of simultaneity, as coupons causes sales and sales leads to more coupons to that customer. In example 1 also, you can think about simultaneity. If the vendor changes the price based on queue length, it is a simultaneity problem. That means if there is a queue, it causes price, and if there is price, it causes, isn't it? If there is a queue, the vendor charges higher price, and if there is some lower price, then there is a long. So price causes queue, and queue also causes price. Okay, so there is a two-way causality, both-way causality between X to Y and Y to X. So both are the cause and effect of each other. The third example is talking about selection bias. That is the movie producer is very much interested in taking those artists who are winning awards, who are award winners, but he is not taking those talented actors who, although talented, they have not got award. Okay, so you know that Dr. Heckman won a Nobel Prize in economics on this topic. Actually, that is, we overestimate the acting quality of an actor if our sample contains mostly award winners. If you have a sample that all are award winners, we think that all the artists are very good. But there are other artists as well, okay, who have talent, who can have awards if they get chance. So these are the three sources of endogeneity, that is omitted variables as in example 1. Then the second one is simultaneity, which you can see in example 2, and the selection bias, which you can see in example 3. Now, what happens if we don't consider, if we ignore endogeneity? Oh, okay, endogeneity problem is there in our model, so let's leave it, let's ignore. No, we can't ignore it because it has a very serious impact. Okay, the model is either underestimated or overestimated. Okay, so whatever effect you are getting from the independent variable, that is not at all exact, because the independent variable is correlated with the error term. So suppose the two variable model, we are concerned with y is equal to alpha plus beta xi plus ui, and you are very much interested in beta hat to find out the effectiveness or responsiveness of x on y, but that beta hat will not give the correct figure, will not give the correct responsiveness if there is endogeneity problem. That means that x is associated with the error term, that x is not independent. It is not giving the total effect of x on y, rather it is giving the effect of x and error term on y. So if we have endogeneity problem, we can either underestimate or overestimate the model. Secondly, you know that if the estimation is not correct, the inference or the hypothesis testing or the statistical inference may be suboptimal, isn't it? The decisions based on inferences from the model could be suboptimal. So when the data scientist fits the model without accounting for endogeneity, the model fit is better. Without model fit, it may be better, but that is actually wrong. Okay, so that is not correct. So one of the most important OLS assumption, as I told you, that data terms are uncorrelated with the independent variables, that is getting violated. So number of possible results, measurement error, omitted variables, and simultaneity. This will be simultaneity. Sorry, it's a typing error. So endogeneity is particularly important in policy settings. You have to have, if you have endogeneity problem in your model, you should be aware of that. You should use some remedial measures to get rid of this endogeneity problem. So if x and e are correlated, then this violates the OLS assumption. This is basically the problem of endogeneity in terms of econometrics. That is, covariance of x and the error term is not equal to zero, and this violates the OLS order least square assumption. Next, the consequences of endogeneity. Endogeneity bias is not a simple violation to deal with. We are just violating some assumption. It's not only that, it doesn't end there. It has serious consequences for the estimates, because the estimates may be underestimated or overestimated. Now, in the presence of endogeneity, OLS can produce biased and inconsistent parameter estimates. You know that the ordinary least square estimators are unbiased and give consistent estimators. Minimum variance, they have got blue property, small sample desirable property, as well as large sample property. But in presence of endogeneity, the OLS can give biased as well as inconsistent parameter. The hypothesis testing can be seriously misleading, isn't it? Because based on the parameter values, you are testing hypothesis, whether to accept or reject a particular hypothesis. But if the parameter estimates are not correct, then hypothesis testing can be misleading as well. Okay, so all it takes is one endogenous variable. If there is one endogenous variable in the model, it will seriously distort all OLS estimates of a model. So you can easily understand the consequence of endogeneity. One endogeneity can distort the whole system, the whole model. So we need to use some way. So we need to use some remedies. We need to use some remedial measures to get rid of this endogeneity problem. So we have got two solutions. One is the ad hoc approach. We can divide, categorize the solutions under two. That is, one is the ad hoc approaches. The second one is the IV estimation, instrumental variable estimation. Okay. First, we will talk about the ad hoc solutions. What is the ad hoc solution? If a dependent variable is potentially endogenous, it is intuitively appealing to look for a proxy that does not suffer from the same problem. The most common, what we are trying to do in ad hoc solution, that means we have to find a proxy for that particular variable, which is endogenous in nature. The most common approach is to let the suspect variable one by one or more periods. That means if suppose xt is endogenous variable, then you can use xt minus 1 or xt minus, that means some left value of xt to use as a proxy for xt. Okay, so the current value of x is being replaced by some past values of x. Okay, so this is the ad hoc solution. Maybe xt and ut are correlated, that is the endogenous problem. But if you consider the lag value of xt, that is xt minus 1 or xt minus 2, they may not be correlated with the error term. Okay, so this is very simple solution. You can understand that, oh, it's very great. It's a great solution that instead of XT, we don't have to search for other variables. We don't have to collect data on other variables. Rather, we can use some lagged values of XT and we can use it as a proxy. So there are some advantages of lagged or proxies. Very simple to implement. We don't have to search for other variable or we don't have to collect data. Additional data requirements limited, intuitively appealing. That means yes, it sounds great. That XT and UT are correlated, but it may be the case that that the past two-year past value of XT may not be correlated with the error term. That means suppose today's price is very much affecting today's sales. But if we think about the price 2 years back, that will not affect much the current purchase decision, isn't it? So that is basically the idea behind ad hoc solution. That means instead of the current endogenous variable, you can use the lagged value of XT so that it will not get correlated with the error term. But there are some limitations of lags or proxies, although it's very easy to implement. There's some limitations. Interpretation becomes a little more difficult since the variable in the regression is only a proxy for the variable we regress. So there is some interpretation problem, loss of precision in some cases, no way of gauging empirically how serious the endogeneity problem is and whether the solution is adequate to deal with or not. That means if there is endogeneity problem, if there is correlation or association between XT and UT, then whether XT minus 2 is correlated with UT or not, that is a little bit difficult to find out. So these are the 3 major limitations of lags or proxies. Next step, the better way is IV estimation, instrumental variable estimation. Okay, so rather than ad hoc solution, although it's easy to implement, it has got some limitations we have seen, and so the instrumental variable estimation may be used. So you know that all the methods have got some advantages and disadvantages. Okay, so it's better to use some battery, some tests together. So different tests are giving different results, and that will be better for the research. Okay, that will help you to understand the outcome of a particular estimation method. So you know that the quality research deals with so many tests. We will call it battery of tests. Instead of relying on one test, because you know that all the methods have got some pros and cons. So instead of relying on a single method, we should go for several alternative methods. Okay, so you know that ad hoc solution is very easy to implement, but rather than ad hoc solution, as it has got some limitations like other tests, you can also go for the IV estimation, instrumental variable estimation method. So the best way to deal with endogeneity concern is the IV technique, instrumental variable technique. So you know that the most common IV estimator is 2-stage least square. You know that most of the examples are basically over-identified. You know that 2SLS, 2-stage least square, is being used for over-identified equation as well as also it is also used for exactly identified equations or exactly identified models. So 2SLS is a very common method of estimation, and this most common instrumental variable estimator uses 2-stage. That means you have to find out the instrument. By the name, you can understand the instrumental variable estimation. How to find out the instrument? So you need to have a technique. You need to find out a technique or formula to find out the instrument. Like the ad hoc solution which uses the lagged value, is not the correct method always. There are some advantages as well as it has some disadvantages as well. So for finding out the instrument, rather than relying on the past value of the endogenous variable, you should think about some proxy which is being given by some method. So 2-stage least square is a particular method of finding out the instrument. Okay, so 2-stage least square method is a method to find out the instrument. You will find in afterward that the generalized method of moment, the method of moments or the generalized method of moment is also an alternative way. It's also a method of finding out the instrument. So these are the methods. We will come to GMM shortly. So for finding IV estimation is the best way rather than ad hoc approach, and for finding out the instrument, you need to have some strategy or some method. You can either rely on 2SLS or you can rely on GMM. Okay, so these are the alternative methods through which you can find out your appropriate instrument for the endogenous variable. So you can, after finding out the appropriate proxy variable or the instrument, you can replace those endogenous variable by their proxies. Okay, so first we will discuss 2SLS, then we will go to the method of moments. So intuitively, IV estimation works as follows. Find a genuinely exogenous variable that is strongly correlated with the potential endogenous regressor. Ensure that the instrument only influences the dependent variable to the potentially endogenous independent variable. So IV estimation works like how that if you can find out genuinely exogenous variable, it will act as an instrument or proxy for the endogenous variable, and that instrument or proxy will not be correlated with the error term. Okay. So the advantage of IV estimation is that IV estimation is intuitively appealing and relatively simple to implement on a technical level. The most difficult part lies in the selection of appropriate instruments. As I told you, the different techniques will give different proxy or instrument. That is, if you use 2SLS, it will give some instrument. If you use GMM, then you will get another instrument. So which is the appropriate instrument? That is basically, that decision is very difficult to take. So you can use different methods. You can use alternative methods to deal with this type of situation. Okay. So the main advantage of IV estimation are that it's rigor and transparency. Okay, you are very much convinced about the method. You know the 2SLS is a standard method, and you are using that method to find out proxy. You know the GMM is a very standard method, and you are using GMM to find out the instrument or the proxy. But in case of ad hoc solution, you are not convinced by that particular situation. That is, you are just using the lagged value. You are not using any standard approach to find out the instrument, isn't it? So the main advantage of IV estimation is that it's rigor and transparent and amenable to empirical testing. That means your appropriateness of instrument, the extent of endogeneity, everything you can understand from the IV estimation method. As the name suggests, this estimate proceeds in 2 steps. Both of them, you know that 2SLS, you are concerned now with 2SLS to find out the instrument. So 2-stage 2SLS means the 2-stage least square. That means you are using OLS in 2 steps. In step 1, what you do? You run the endogenous variable on all the exogenous variables as well as the instrument. Suppose your endogenous variable is X and X1, suppose. And suppose your other exogenous variables in the model are X2, X3, and X4. And you have also instruments. Suppose Z1, you can use sufficient number of instruments, Z1, Z2, Z3. You know that you have one endogenous variable X1. So what you have to do, you run the X1, run the regression X1 is a function of X2, X3, X4, Z1, Z2, Z3. You can use as many instruments as you can. That's better method. You can choose between the 3 because you have to replace only one endogenous variable, isn't it? But you can use more than one instrument. So to find out which one is the best one. Okay. So after that, what you are doing, you are getting some X1 hat, isn't it? You are getting some X1 hat, which is free of the endogenous endogeneity, which is free of endogeneity, and you can replace that X hat by that X1 by X1 hat. This is the second stage regression, and you can run your regression, original regression. Okay, so run the predicted values for the first stage regression in place of the potentially endogenous variable. Suppose your model is Y is equal to X1 plus X2 plus X3 plus U. So X1 is the endogenous variable. After running ordinary least square method in the first stage, that is X1 as a function of all exogenous variables in the model and the instrument, you are replacing X1 by X1 hat. In the second step, what we will do, we will run the original regression. Y1 is equal to X1 hat plus X2 plus X3 plus some error term Vi. Okay, so in this way, you can get rid of the endogeneity problem in the model. So the first stage cleanses the endogeneity from the variables we are worried about. By using the predicted values based on genuinely exogenous variables only, we obtain the exogenous part of their variation, that is x1 hat. The second stage uses a variable that is now exogenous thanks to the first stage. And so the biases appears. That is now you are running the regression y is equal to alpha 1 x1 plus alpha 2 x plus alpha 3 x3 plus uy. And instead of xi, you are using xi hat, which is being obtained from the first stage. So the interpretation of the parameters and hypothesis testing can all take place as usual following the same procedure as OLS. But the hard part about TSLS is not the estimation but the data. You have to have a good number of data, isn't it? You have to run the regression, you have to have data on the instrument, that is Z1, Z2, Z3, and you can incorporate it in the first stage to run the regression and to get x1 hat. So for one potential endogenous variable, we need at least one instrument. For two, we need at least two, etc. That is, if you have x1 as the endogenous variable, you need at least one instrument, say Z1. But as I told you just few minutes before, that if you want to increase the number of instruments, that will be better, and you can choose. You can understand which instrument is the better one among the three. Suppose for one endogenous variable x1, you are using Z1, Z2, Z. So you can look at all the three proxies, all the three instruments. Which one is the better one? Which is more effective? Okay, and you can use that. But if you have one endogenous variable, you should incorporate at least one instrument variable. For two endogenous variables, x1 and x4 endogenous, you need to have at least two instruments. Okay. Now, what is the valid instrument? It should be correlated with the endogenous variable. That means if you are taking Z1 as the instrument for x1, so Z1 and x1 should be strongly correlated. And another requirement is that Z1 should be exogenous in nature, because you're replacing x1 by Z1, and Z1 should have two properties. It should be correlated with x1 and it should be exogenous in nature. Okay, so these are the two requirements for a good instrument or for a potential instrument. So IV estimates have some important property. IV estimates are only as good as the instruments used. We need to run some statistical tests and make sure the model is working properly or not. That means you should, after running the regression with the instrument, by replacing the endogenous variable, you should think about the intuitiveness. That means that logic behind it, whether it's working, whether you have not changed the initial model or not, because you want to run the same model but with some instrument instead of the endogenous variable. So you should have to make sure of the model with which you are running, that whether it is working, it is the same model with which we have started with or not. We should not change the model. We should change the variable for the endogeneity problem, because it's a very serious problem, but we should not change the model. We should not change the inherent or the underlying logic or the underlying nature of the model. Okay. So although it's called two-stage least square method, avoid running the two stages separately. That means you know that all the different packages are being worked to find out two SLS estimators. So two SLS is being done simultaneously. It's not done one after another. Okay. So two-stage least square, avoid running the two stages separately. You will get incorrect standard errors, too small, and you might mistakenly exclude the exogenous variables from the main model, like common error. So, the packages, what they're doing is that they're running the two stages simultaneously, not one after another. So we can summarize whatever we have learned till now. We can summarize. Endogeneity can be a very serious issue. It results in wrong coefficient signs, significance level. That is, it may lead to underestimation or overestimation of the model. So we can get rid of the endogeneity problem with the help of two solutions. One is the ad hoc, and there is the IV, instrumental variable estimation method. You know that the IV estimation is only useful if the instruments are good, because we are dependent on the instrument. We are replacing the endogenous variable by the instrument only. So the instrument must be very good. The instrument must be strongly correlated with the potential endogenous variable with which you are replacing. That means if Z is the instrument, that should be correlated, strongly correlated with the endogenous variable, say x1, and that Z should be genuinely exogenous to the model. That means it should be exogenous, that it should be affected by some factors which is outside the model. Isn't it? Some exogenous factors may affect Z, but no internal factors or no factors within the model can affect. So Z should be exogenous and Z should be strongly correlated with the endogenous variable, say X. So whenever possible, over-identify the model. If you over-identify, you know that you can easily use 2SLS, which is least square method. Okay, it allows you to test for instrument exogeneity and also excludability. Okay, so this is all about 2SLS. So you can see that IVS, you can get rid of the endogeneity problem with the help of two solutions. One is the ad hoc solution, which has got some disadvantages, and the second one is the IV estimation, which is a much better method of handling the endogeneity problem. But IV estimation requires some standard methods to find out the instrument. So either you can go for 2SLS, which is a very common method, or you can go for the generalized method of moment. It's a very cooler method, a cooler way of doing IV estimation. Okay, so identical to 2SLS for just identified models, you can use more precise estimates with over-identified models as well. So 2SLS can be used for over-identified as well as just or exactly identified or just identified models. Same is the case for GMM as well. GMM you can use for over-identified as well as just identified models as well. Now we are linking some some are already, you have already learned, okay, some concepts of endogeneity and some are a little bit new to you. So endogeneity is linear regression. Okay, endogeneity refers to a situation in which a predictor, that means Y, in a linear regression model is correlated to the error term. So we call such a predictor as endogenous variable. Okay, that if a predictor, that means if a particular explanatory variable, say X, is correlated with the error term, then we call that predictor, that exogenous variable, say X, as endogenous variable. The coefficient estimate of the endogenous variable is no longer blue, best linear unbiased. It loses the blue property. Endogeneity, why? Because endogeneity violates one of the classical assumptions of linear regression model. That means the independent variables are uncorrelated with the error term. So in case of endogeneity, in the presence of endogeneity, the independent variables are correlated with the error term. So what we do, we are actually violating one of the important assumption of CLRL, and hence the estimators are no longer blue. On the other hand, if a variable is exogenous, so it is being directed by some sources or some factors which are outside the model. Exogenous variables determine factors outside the model. So endogeneity and exogeneity, or endogenous variable and exogenous variable, can be separated very well. Okay, so exogenous variable is a variable which is determined by factors outside the model, whereas the endogenous variable is a variable which is determined inside the model. That means there is some association between the endogenous variable and the error term. Now, as we have already learned, the common source of endogeneity can be classified as omitted variable, simultaneity, measurement or selection bias. And can you remember the three examples? Omitted variable is all about example 1, simultaneity about example 2, that is the merchandise store example, and there is the coupon, isn't it? Can you remember? And the selection bias or the measurement is basically talking about the third example, that is the example of a movie producer. How he is taking, or he is inviting the artists, what award winners only. So we will give some diagrammatic presentation of those three sources. Source one is the omitted variable. So you can see the arrow. This is the independent variable X is linked with the response variable Y, and this is very common in the linear regression. You can say X is the cause and Y is the effect, but the alarming situation is here in the below. You can see that there's a confounding variable Z. We call such variable as confounding variable Z, which is related with Y, and which is related with Y, and we can incorporate it in the error term, because this is not incorporated in the model, and it is incorporated in the error term because this is related with Y. But this relationship, that means from Z to X, this is dangerous. This actually causes the endogeneity problem. So when Z is correlated with the X, the independent variable, this is basically the endogeneity problem. So we have to break this chain. We have to break this relationship from Z to X. Because in that case, what happens? Z is correlated, Z is in the error term because it is not included in the model. So it is in the error term. So error term and the independent variable gets correlated. So if a confounding variable is what I have just told you, if a confounding variable Z is omitted in a linear regression model, then the affected variable would become endogenous, because in this case, the unexplained variable Z leaks into the error term. It is not incorporated in the model and it is incorporated in the error term. Then the affected predictor will be correlated, that is X will be correlated with the error term. It means we have an inaccurate causal effect, isn't it? We cannot find out the separate effect of X on Y. Rather, we can find out the effect of X and the error term on Y. So that is basically the inaccurate. We cannot find out the effectiveness of X. Isn't it? We cannot find out the accurate effectiveness of X. So that is basically the inaccurate causal effect. If the confounding variable Z is added in the linear regression model, then the affected predictor would no longer be endogenous. If you add that variable Z, then it's okay. Like the first example, the vendor has omitted or has missed to talk about the temperature in the regression equation. So if we can, along with the price, if we can use Z, the temperature variable in the regression equation, then it's okay. And that will give the optimal solution. There will be no endogeneity. Okay, because Z is not incorporated in that error term. Z will be treated as separate variable. Z has some effect on Y. That is okay. You can get the parameter of Z and you can find out the sensitivity of Z on Y. But if Z is not included in the variable, in the model, that's the problem. That causes the endogeneity problem. Okay. So if you add Z in the linear regression model, the coefficient estimate for the treatment effect would be no longer be biased. It will be unbiased. That means you can find out a separate effect of X on Y as well as a separate effect of Z on Y. There will be no problem at all. It will be 3 variable model instead of 2. The second source is simultaneity. We can think about simultaneity problem by thinking about the second example, that means the coupon giving example by merchandise store. So simultaneity, another common cause of endogeneity. Simultaneity arises when one or more of the predictors is determined with the response. That means X causes Y and Y causes X. There is a two-way or both-way causation from X to Y and as well as from Y to X. For example, we can use education level to explain the household income, because people with higher education tend to earn more. Similarly, we know that people with higher income are easier to afford higher education. So you can say that there's a both-way causation from education level to household income, and from household income, those in household who have got higher income, they can afford to have higher education. Okay, so typically such relations can be explained by simultaneous equations. You know, they're also called structural equations. So this is basically the simultaneity problem. This is another cause of endogeneity. That means we will come to the most important concept is the simultaneous bias. Okay, where the bias lies. So simultaneous equations we will explain with the example. Where we have two equations, y is equal to alpha x plus v, where use the error term, and x is equal to beta y plus v, where v is the error term. So you can say that y is related with x as well as x is related with y. So there is a two-way causation. You cannot call x as cause and y as effect, because in the second equation you can see x as effect and y as cause. So both x and y are acting as cause as well as effect. So y causes x as well as x causes y. So this is the simultaneity problem. You know that by solving the two equations above, we have a reduced form of the model. Reduced form means we will solve the two equations y and x, and we can express y as a function of parameters and error term, and we can also express x as a function of the parameters and the error term. That means in the structural equation, you can see that y and x gets mixed. In the right hand side, there is another variable x, which is endogenous, because in the next equation you can see that x is the effect, isn't it? And here in the first equation you can see that x is the cause, and in the second equation you can see y is the cause, and in the first equation you can see y is the effect. So when you are transforming the the structural equations to the reduced form, then you can get rid of the endogeneity problem. That is, y is a function of the parameters and x is the function of the parameters. So in the context of causal inference, if the treatment effect x is determined by the response variable, that means if x is determined by y, easy to see that that there is some association between the explanatory variable x and the error term u. That means if x is not exogenous in this equation, you can see here, you can see that if you think about the first equation only, y is equal to alpha x plus u. So if x is not determined by y, if x is the cause and y is the effect, then it's okay. But if this, look at the second equation, here you can see that x is determined by y because y is the cause and x is the effect in the second equation. So if x is determined by y, then obviously x is correlated with the error term. If x is determined by some factors, observable or unobservable, then obviously here you can see that you can observe the variable. X is determined by y. So obviously in that case, if x is determined by some variable which may be observable or unobservable, it is always correlated with the error term. Okay, and that is the endogeneity problem. The simultaneity problem, you can see that the observed variable is the variable is observed. It is affecting x is basically observed and hence it is correlated with the error term. Now you can find out the covariance of xu. You can see that it should be 0 according to classical assumption. But here you can see that covariance of xu is not equal to 0. That means there is some association between the error term and the explanatory variable x. Therefore, both the treatment effect, that means x and the y, are endogenous variables, and if you apply OLS, it will lead to a biased estimator of x. That means simultaneity bias. If you apply OLS to this equation, it will give some biased estimator, and that is called simultaneity bias. This is very important. You know, the concept of simultaneity bias is very, very important. Therefore, the treatment effect, that means x, can never be the true effect. There is always some simultaneity bias. The estimator is a biased estimator. Now let's think about a very common example, simple Keynesian model. You know that macroeconomic simple model SKM. Okay, simple Keynesian model. You all are aware of this. It's simple. I think the economics management students and other, is there any other discipline other than economics and management? Hello, can you hear me?
Madam, all are from management, commerce, and economics.
Huh?
Most of them are from commerce, economics, and management.
Commerce are also there. So commerce students, you also have heard about simple Keynesian model, is it? Simple Keynesian model you have heard? No. Yes or no?
Please respond if someone is from commerce.
Yes,
No.
yes. Yes.
Yes, okay. Sound is breaking actually. Oh, okay, then it's okay. So I'm just giving a simple example and I'm skipping it. Okay, that's it. You can see that it's a two equation model. C stands for consumption and Y stands for income. So you can see the first equation is related with consumption equation, and second equation is the income equation. You can find in the first equation, Y is the cause and C is the effect. But in the second equation, you can see that Y is the effect and C is the cause. So you can say that there is simultaneity between C and Y. That consumption and income are the cause and effect, are both acting as the cause as well as the effect in either equation 1 or equation 2. You can say that for IT, there is no separate equation, and hence it's an exogenous variable. So covariance between error term and IT is 0, but whereas the covariance between YT or rather CT and error term is not equal to 0. And this is basically the simultaneity problem. Covariance between I and U is 0, but covariance between B and U is non-zero. So application of OLS to the consumption function results in biased and inconsistent estimate, and this is called simultaneity bias. That means if we have some simultaneous kind of relationship, that means the X and Y are the cause and effect are acting as both cause as well as effect in any of the equation, then we have some. But if we ignore that problem and we apply OLS, then we will have some simultaneity bias. So you can see that alpha hat we usually have in the or after using ordinary least square method, you can know that alpha hat is equal to alpha. Expectation of alpha hat equal to alpha gives some biased estimate. But you can see that alpha hat, if you x prime x whole inverse x prime, if you expand it, finally you are getting alpha hat is equal to alpha plus x prime x whole inverse x prime mu, which is not equal to 0, because you know that x prime mu is equal to 0. If you took the expectation of this part, then you will get expectation of alpha hat equal to alpha plus 0. But because expectation of xu equal to 0, but here expectation of xu is not equal to 0, because error term and the explanatory variables are correlated, isn't it? So it gives some biased estimate. Alpha hat is no longer an unbiased estimator of alpha. Okay. The third is the measurement error. In a linear regression model, measurement error, we are talking about the third model. That means the third example. That means the example of the movie producer. In a linear regression model, it assumes that the observations are correctly measured without any error. This assumption gets violated in some situations. So, for example, like people's ability and willingness to exercise. These are not measurable. You know that how do you measure people's ability or willingness to exercise? So instead of correctly measuring it, we use some proxy. That means people's IQ scores can be used as a proxy for people's ability, or willingness to exercise can be proxied by number of hours in the gym. Okay, so some proxy variables are being used. Sometimes it is hard to take correct observation. For example, age variable. Age variable, if you don't have, you cannot have age variable in integer. Maybe some integer, month and day. But what we do is that we generally ignore those months and days and we take the integer values only. So it is very difficult to correctly measure some variables, and sometimes some variables cannot be measured directly and some proxies are being taken. In these cases, the true value of the variables are not included in the model. The difference between, so same is the case for example 3, that means the movie producers are considering the award winning artist as the very good talented artist. But he is doing some measurement, he's committing some measurement error, because other than the award winners, there may be some other talented artists as well, who may be more talented, but they have not got the award due to so many reasons. Okay. So this is basically the measurement error. So scenario 1, there can be two scenarios. When the measurement error is the dependent variable, it's not a problem. It's not a case of endogeneity. Isn't it dependent variable measurement error to the dependent variable? If it is present the dependent variable, it doesn't cause endogeneity. But if the measurement error is in the explanatory variable, that problem causes endogeneity. Because if the measurement error is in the explanatory variable, there will be deviation from the true value and the observed value. Let x star is the observed value and x is the true value. So the difference between x star and x, this deviation is the measurement error, and that may cause some endogeneity problem. Suppose x equal to x star plus b, and b is the measurement error. We set up a linear regression as usual without including the measurement error because it is not measurable. So y is equal to beta x plus epsilon we are running. Then the model we are actually estimating is instead of x, we are replacing x by x star plus b, and y, the equation becomes y is equal to beta x star plus u. Okay. So if you find out the correlation between error term and x star, then you will see the correlation between covariance between x star and u is not equal to 0. So obviously, if the covariance is not equal to the correlation is also not equal to 0. So you can see that the explanatory variable and the error term are correlated. So this causes endogeneity problem in case of measurement error. So beta hat, you can also calculate beta hat. Beta hat is no longer equal to beta. Rather, beta hat is equal to, finally what we are getting, beta hat is equal to beta into multiplied by variance of x by variance of x plus variance of y. And you can easily see that variance of x by variance of x plus variance of y, this part is basically less than 1 because it's a ratio. Because variance of y cannot be 0 or it cannot be negative. It has some positive value. So it's a ratio. So beta hat is less than beta. So that is basically giving some serious problem. That means beta hat is no longer equal to beta. Okay. So some biased estimates are being obtained. So remedy of endogeneity we have already discussed. That is, we can either use ad hoc approach or we can use 2SLS method for removing endogeneity. Okay, so here you can see the endogeneity problem. The error term is related with y, that is okay, but the error term is related with the independent variable x. So this is the serious problem. So what we have to do, we have to use an instrument variable such that the relation that we are using some instrument z instead of x, and this z should be correlated with x, but this z should not be correlated with the error term, isn't it? This z should be correlated with x. This is the requirement of instrument. This z should be correlated with x, but this z should not be correlated with the error term. So this is the essence of a good instrument. So we have already learned two-stage least square. That means we should rely on some standard method to find out the instrument. Okay, so two steps you can this is step one. With the help of diagram, you can see that this is step one. That instrumental variable, independent variable, and the independent variable is expressed as a function of other independent variables as well as the instrument, and you can find the fitted independent variable. That means x1 hat. And in step two, what you are doing, fitted independent variable is taking as the dependent variable, and you can run the regression. Fitted independent variable is taking as the proxy and is the instrument for the endogenous variable. That means instead of x1, now you're using x1 hat, which is obtained from the stage one, and you can run the original regression y is a function of other independent variables as well as x1 hat. So what is the major takeaway? That is, when using a linear regression model, draw a causal inference endogeneity is the issue we need to address. Okay, so in a linear regression model, the final goal is to make some inference, isn't it? Some statistical inference is to be made after estimation, after hypothesis testing. Our final objective, our major goal is to draw some conclusion or inference. So endogeneity is a serious issue we need to address. Otherwise, we would get a biased treatment effect to omitted variable simultaneity or measurement error. Now come to the method of moments. Okay, so in statistics, the method of moments is basically an estimation method, just like other method of estimation. Like you are very much habituated with the ordinary least square method. You are very much habituated. You have all learned, I think, about the maximum likelihood estimation method. Okay, it's a non-linear method, isn't it? Ordinary least square method deals with linear regression model, whereas maximum likelihood estimation method may be used for the non-linear model as well as linear models. So OLS method is applicable to linear model only, whereas maximum likelihood estimation method can be applied to linear as well as non-linear model. So you can understand that MLE is a much common method, is a much popular method because it can deal with linear as well as non-linear method. Why I'm talking about MLE, that you will be learning shortly, you will be understanding shortly. It is the method of moments is basically helpful for estimating the maximum likelihood estimates in the first stage. You know that MLE is basically an iteration method. Several iterations are being run. Okay, so if you go on running the iteration, the first iteration is the method of moments. So using the concept of method of moments. Okay, so method of moment is an estimation method. It's a very simple method, very easy method. You know that what you have to do, the method is that you have to equate the population moment with the sample. You know, the first moment is the mean. So you can equate population mean with the sample mean. That means mu is the population mean. And what is the sample mean? X bar. So mu equal to X bar. So X bar is the estimate, method of moment estimate of mu. Similarly, you can equate the second population moment with the second sample moment. That means, you know, that variance is the second population moment, and sample moment is the standard deviation. So you can equate standard deviation with the variance to find out the you can expectation of xi minus mu whole square. This you can equate with sigma square. Okay, so standard deviation square is variance. So you can equate the population variance with the sample variance to find out the second moment. Okay, second moment. So the number of such equations is what we have to do, that the population counterpart should be equated with the sample moments or the sample counterpart. the number of such equations the same as the number of parameters to be estimated. That means suppose you have to estimate two parameters, then you have to have two equations. That means equating the population moment with the sample moment. Although suppose you are interested with the estimation of one parameter, okay, but you have so many, you know that you have so many moment conditions. The first moment mean mu is equal to x bar. The second moment variance is equal to expectation of xi minus mu whole square. Third moment is the skewness. Fourth is the kurtosis. So many moment conditions are there. But if you're interested in finding out one parameter, you have to have only, you can use only one equation, one moment condition only. So this is the limitation of method of moments. Although you have several moment conditions, but for estimating the number of parameters, you have to use only that number of moment conditions only. You cannot use other moment conditions. If you are interested, if you are required to find out two parameters in the model, you have to use only two moment conditions. You cannot go for the higher order moment conditions. But you know that if you go on using other moment conditions, you are just using other information from the population, but that has been restricted in the method of moments. So although method of moment is very simple method, you can see that if you can equate the population counterpart with the sample counterpart, you can estimate the parameter. But the disadvantage of this method is that you cannot go on using the information for more number of parameters. Number of information, number of moment conditions will be equal to number of parameters. But if the number of moment condition is greater than moment parameter, number of parameters, which is the usual case, you cannot use method of moments. Method of moments cannot exploit what you can understand from this, that method of moment cannot exploit all the information from the population, isn't it? So those equations are, so comes the generalized method of moments. Generalized method of moments can use all the available information from the population. You can use as much number of moment conditions for estimating any number of parameters. Suppose you are interested with two parameter estimation, but you can use 5 moment conditions. Suppose you're interested with only one parameter estimation, but you can use more than one parameter, one moment condition for generalized method of moments. Okay, so with generalized, you can easily understand the generalized method of moments is much more accurate. It is it gives some unbiased estimates. It gives the minimum variance or efficient estimates, whereas the method of moment estimates, although maybe unbiased, but it loses the property of minimum variance. It's basically inefficient. Whether the generalized method of moment GMM it gives biased estimate, unbiased estimate, as well as it is efficient. It has got the minimum variance among the class of all unbiased estimator. It gives minimum variance unbiased estimator. Whereas the method of moments, although give by unbiased estimators, but its the minimum variance is not at all minimum. It cannot give minimum variance estimate. Okay. Sometimes it has some problem. Method of moments. So we are coming to that. The solutions are estimates of those parameters. Okay, the same principle used to derive higher moments like skewness and kurtosis. So mean, variance, skewness, kurtosis, all you can for all conditions you can use for finding out the parameter. The method of moment was introduced by Pafnati Chebyshev in 1887. The proof of you have learned about the central limit theorem. So while doing the proving the central limit theorem, Chebyshev has introduced this concept of method of moment, and the idea we can date back to Pearson. Okay, Pearson, you all are aware of the name Carl Pearson. Okay, so Pearson's correlation coefficient. Okay, then we have some advantages of method of moments. It's very due to easy computability. Method of moments estimate maybe even the first approximation to the solution of likelihood equation. As I told you that MLE and method of moments are related because MLE is an iteration method. In the first step, method of moments can be used. The first approximation to the solution of the MLE can be obtained from method of moments, but the successive iterations can be done by Newton-Raphson method. That is a different thing, but method of moments can assist in finding out the maximum likelihood estimates. So the advantages and disadvantages of method of moment. The method of moment is fairly simple and yields consistent estimators, though these estimators are often biased. There's an alternative to MLE. However, in some cases, the likelihood equation may be intractable without computers, because you know that likelihood equation are dealing with non-linear equations. So it's very much difficult to compute manually. So we use computers, or maybe sometimes we are very much we are facing very much problem issues with the computers as well. Okay, so method of moments in that case is a very simple method. It can estimate the parameters very easily. Okay, and in this way, the method of moment can assist in the first step. The method of moments can assist in finding out the maximum likelihood estimates. So method in what we do in the method of moments, we have already discussed that we equate the population mean with the sample counterpart. That means that if you're interested with the first moment, that is the mean, population mean is mu, and where the sample mean is x bar. So mu x bar is the population moment or the estimator of mu. The second moment condition involves variance. So population variance is variance of x equal to sigma square, and the sample counterpart is expectation of x minus mu whole square. The expectation of x minus mu whole square equal to sigma square is the unbiased estimator of variance, that is summation xi minus mu by sigma whole square. So advantages and disadvantages we have already discussed. That is, the method of moment is very easy to handle. It's very simple method. Equate sample moments to parameter estimates, and they are very much available. Method of moments are very much available. They have the advantage of simplicity, but the disadvantage is that it doesn't give optimal property. That means the minimum variance property gets violated, or median variance sometimes gets violated with the help of method of moment estimation method. The method may not result in sufficient statistics, and it may not take into account all of the relevant information in the sample. As I told you that if you're interested in estimating one parameter, then you can use only one moment condition, but you have other moment conditions as well, but you have to skip those information. That means it is not using all the relevant information. Okay. So comes the GMM, generalized method of moments. This generalized method of moments is a very useful method. It is basically applied in the context of semi-parametric models. That means you know the semi-parametric models. Okay, so in the semi-parametric model, we generally use the generalized method of moments. It is basically an alternative to MLE, because we are trying to find out the instrument. Let's not forget about the endogeneity problem. We are relating endogeneity with GMM. GMM, although it's an estimation method, but we should also think about the endogeneity issue, because we are using for finding out the instrument, for finding out the potential instrument, we are using the different methodologies. Like first we have learned to use 2SLS, that is the IV estimation. For the IV estimation, we are finding out instrument by using 2SLS. Now we are learning to find out the instrument with the help of generalized method of moments. Okay, so it is quite natural that we want to use the most information available, and GMM does that. GMM uses all the moment conditions, uses all the information available in the population. But unfortunately, the method of moment estimate cannot incorporate more moments than parameters. I told you before that if you have one parameter, one moment condition will be considered. It cannot incorporate more moments than parameters. The GMM estimators are known to be consistent, asymptotic, normal, and efficient in the class of orders. It has got a minimum variance and do not use any extra information aside from that contained in the moment conditions. Moment condition, whatever information is there, it accommodates all the information. In the method of moment estimator is a consistent but inefficient estimator, whereas the GMM gives consistent as well as efficient estimator. Now, if we had the same number of moment conditions as unknown parameters, so suppose you have k number of parameters and you have k number of moment conditions. So what you can do, you go on solving the k equations and you can estimate the k number of parameters. But Hansen has asked that what happens when we have more conditions than moment conditions than the parameters, as usually occurs in econometric models. Suppose we are interested in one parameter estimation, but we have more than one moment condition. How can we combine them optimally? This is the purpose of GMM. In GMM, We estimate the parameter vector by minimizing the sum of squares of the differences between the population moments and the sample moments, using the variance of the moments as a metric. You know that all the estimation method has got some background. Like the ordinary least square method, what it does, it is being done by minimizing the residual sum of squares. MLE, how it can be done? It is being done by maximization of the likelihood function. Similarly, in the GMM as well, in case of GMM, generalized method of moment is also an estimation method like that of OLS or 2SLS or MLE, and it is being done by minimizing the sum of squares of the differences between population moments and the sample moments using the variance of the moment at the second moment as a metric. So this is the minimum variance estimator in the class of estimators that use moment conditions. That means it has got the minimum variance property. It is an efficient estimator. Suppose, let's consider an example, that is, suppose we have a sample at hand, which is the result of n independent draws from a Poisson distribution. Now you know that Poisson distribution has only one parameter, that is lambda. The expectation of x is lambda, variance of x is also equal to lambda. So it is only one parameter. So if we are having a having an independent draws from a Poisson distribution, then we are interested in only one parameter. So the method of moment estimator of lambda could satisfy the system of equation based on the sample moments. Okay, so method of moment will use only one moment condition. Now we have two moment conditions and one unknown parameter. We know that for the Poisson distribution, we have mean, we have variance, isn't it? So we have two moment conditions, but one unknown parameter, that is lambda. So how can we accommodate two moment conditions for finding out lambda estimator for lambda? We cannot use it for method of moments. So comes the generalized method of moments. So when we could use only p number of moments to estimate the parameters. That means if you have p number of parameters, then you can use p number of moments with the help of method of moments. But if you have more number of moments than the number of parameters, then the additional moments will be ignored by method of moments. That means we are losing some information in case of method of moments. But the generalized method of moments can take into consideration all the p number of moments when estimating only lesser number of parameters, say q, and q is less than p. So the remedy for the situation was introduced to the econometrics literature by Hansen 1982 in his famous article. It's called the generalized method. So generalized method of moments is being introduced by Hansen in 1982, and it is a much popular method. The idea behind GMM estimation is that once it is impossible to solve the system of equation provided by method of moments, then we can go for GMM. Okay, and note in the population, still all moment conditions hold, and the problem arises because we have a finite sample, and GMM can take into consideration all the different conditions or all the different information contained in the population. The GMM model that better controls for the three sources of endogeneity are unobserved heterogeneity. You know that there are different types of endogeneity problem, different sources of endogeneity problem are there, and we have learned about the three major categories of endogeneity problem. Okay, so GMM can better handle three sources of endogeneity. One is the unobserved heterogeneity, then simultaneity, and dynamic endogeneity. These three types of endogeneity can be better handled by generalized method of moments. And if you have other types of endogeneity problem or the other sources of endogeneity, you can go for 2SLS, because you have to have you have to apply the instrumental variable estimation method, and you have to have an instrument for replacing the endogenous variable. So basically, the GMM estimator is a way of exploiting information because it can accumulate all the information in the population, and when the number of moment condition equals the number of unknown parameters, GMM is equal to MM. Isn't it? Generalized method of moments gives the same solution like that of the method of moments. The number of moment condition is equal to the number of parameters. But when Q is greater than P, that means the moment condition is greater than the number of parameters, the GMM estimator it will be the better one, as it gives the value of theta, which will lead to the closer value of moment condition, and is the solution, and the closeness reaches to 0 or tends to 0. Next comes system GMM. So I think that it's a little bit difficult for you to take all the things at a time within these 2 hours, but I'm helpless actually.
Ma'am, can you explain again the Q is greater than P part?
Hello? Can you repeat?
Can you please explain Q is greater than P part? That
Yes, it's obvious. Now see that Q is the number of moment condition and P is the number of parameters. If Q and P are same, that means the moment condition, suppose you are to estimate only 2 parameters, okay, and you have 2 moment conditions, then you can use the method of moments very easily. That means 2 moment conditions are there and 2 parameters. That means suppose you are interested in mu and variance, mu and sigma square, then you can use the 2 moment condition and you can estimate the parameters mu hat and sigma square with the help of method of moments. But if you have more moment conditions than the number of parameters, that means if you have, suppose you are interested with, or you want to exhaust all the moment conditions, say 4 are very well known and standard method of moment condition, that is mean, variance, skewness, and kurtosis. Suppose you want to exploit all the 4 information, okay, but your number of parameters to be estimated is equal to 2. You cannot do it with the help of method of moments. So when Q is greater than P, that means the moment condition is greater than the number of parameters to be estimated, then GMM is the way out. GMM can accommodate all the information on mean, variance, skewness, and kurtosis, and it can estimate mu hat and sigma square hat. You can estimate, we can find the estimator for mu and sigma square. Okay, so this is the essence of GMM. GMM can accommodate all the condition, it can and it can also use all the information, whereas method of moment fails actually. Okay, is it clear to you right now?
Yes, ma'am.
Okay, thank you. Next comes system GMM. So you know that system GMM, by the name you can understand it has got some more than one equation. System GMM, or you can either deal with one equation or more than one equation. So GMM generalizes the method of moments, isn't it, by allowing the number of moment conditions to be greater than the number of parameters. So this we have already discussed. So generalized method of moments actually deals with the number of moment conditions to be greater than the number of parameters. Using this extra moment condition makes GMM more efficient than method of moments. So this is the advantage of GMM. What the system GMM does, it is basically an improvement over GMM. GMM is an improvement over MM, whereas system GMM is an improvement over GMM. Or rather, you can say that system GMM suits to particular situation where there is more than one equation. Okay, the system GMM estimator is dynamic panel data model. Okay, the dynamic panel data model combines moment conditions for the difference equation with moment conditions for the modeling levels. You can consider the difference equation, that means the first difference equation or the second difference equation, and you can consider the actual model, that is the modeling level, and you can find out the estimator, or you can estimate the parameters. An initial optimal weight matrix under homoscedasticity and non-serial correlation is not known for this estimation procedure. So for the system GMM, we have to correct the heteroscedasticity, we have to correct the autocorrelation problem if any, and we can use some weight matrix and we can estimate the parameters. So it gives a much better method. So it's a system GMM estimation method is a much improved method, and we can use that method to estimate the parameters. Okay. Now these are the standard references. If you're interested more with the problem of endogeneity, method of moments and all, then you can go through these 2 standard papers. Okay, these are path-breaking papers, you can understand. So thank you. This is all about the theoretical part. Let's go to the econometric part very quickly. As this is FDP, a faculty development program, and you have learned so many theories, so many basic issues, ideas about the endogeneity problem, or rather the method of moments, and generalized method of moments, and the system generalized method of moments. You need to know, have some idea about the package, how to run the regression, the most important question with which we deal with while doing research work. So I'm going to show you a panel data Okay, I have set an example in the Excel sheet, an example of panel data, and I will show you how to run the generalized method of movement. Okay, GMM. Method of movement is generally not used. Rather, the generalized method of movements we have understood already that it is much standard method. Okay, so let's first open the eViews. eViews 8 is already open. Okay, let's click on eViews. This is eViews 8. Okay. Now, first we will copy our data is in the Excel sheet, and we will copy the data from the Excel sheet to the eViews file first. So what first we will have to do? It has got two parts. First is the data entry. After data entry, we will run the regression. Okay. So first go to file, then new, file, new, what file? So as we are concerned with panel data, we have to choose the balanced panel option. Our start date, I am showing you the Excel sheet. Our start date is 1971. Okay, and the end date, the starting year is 1971. The end date, that is the last year, is 2011. Okay, and number of observations you will see, it will be equal to 11. Click on OK. I am showing you the Excel sheet. Click on OK. Go to quick to know how to enter data or how to copy data. Then empty group. Take the cursor at the first cell. Okay, now this Excel sheet is open. You see that this is the data set. That means I have considered 11 states. Okay, see Andhra Pradesh and then Assam. In different states, your state is also there. Assam. So many of you are from Assam, Bihar, and so this way you will be having 11 number of states are there. So panel data has been arranged in the Excel sheet. 11 states has been considered from 71 to 2011, and the Y output is basically the data on agricultural sector output, and the inputs are seed, fertilizer, manure, area, and total labor. Okay, so at 1, 2, 3, 4, 5 inputs are here. Then these are the log values: log of seed, log of fertilizer, log values of all the 5 inputs. Okay, now what we will do, we will select the data, and we will copy it and paste it in the eView sheet. You can see all the states are there, 11 states are there. Now copy this data and then paste it. Okay. Now what we will do, we will go to the quick menu again. Go to quick button, estimate equation, click on estimate equation. Then you have to write the command. That means first you have to write the output and then the input. The output give and input separated by a single space. So I have already written the command just for saving time. I'm showing you. While doing your research paper, you can also type it in the separate Word file. That will be easy. Instead of typing in the eViews file, if you can write it in the Word file and then copy it, it will stay as well, isn't it? So you can type in the Word file and you can copy it. See, can see that output and then a constant term. See, constant term is the intercept term. That means the regression with intercept term, and then all the inputs separated by single space. Now copy it. Okay, and then again you go to eViews file, you paste it here. Okay, after pasting, you have to select the method. Here least square is coming as default. Now we are interested with generalized method of moments or dynamic panel data. Can you do the third option? Generalized method of moments. Can you all see? Generalized method of moments or dynamic panel data. Click on that. Okay, we have chosen generalized method of moments or dynamic panel data. Now go to panel option. After writing the specification and choosing the estimation method, go to panel options. Go to panel option. Now here, what you have to do first, you will be given two options: fixed effect or random effect. Because you know the panel, we are dealing with panel data, and hence here are two options. Suppose as we have 11 states, the cross section effect is I may be dominating. So let's select the fixed effect. Okay. Then GMM weights. The GMM weights 2SLS will come as default. Now we are more interested with cross section. Cross section should similarly unrelated regression equation. So cross section should, and in the coefficient covariance method, you can choose white cross section. So what it will do, white cross section will automatically correct the autocorrelation or heteroscedasticity problem, if any, in the data. So you will be having an estimate which is free of autocorrelation and heteroscedasticity. And if there is any contemporaneous correlation, cross section should, you can see that seemingly unrelated regression. That if you have any contemporaneous correlation, that will also get corrected. Okay. Now, what we have to do? We have to give instruments, because we are dealing with endogeneity problem, isn't it? So GMM, if there is an endogeneity problem, we have to deal with that. Suppose we have created some instruments as well. Let me open the Word file. Some instruments are there. That means seed, fertilizer, all the inputs I have already used as instruments. Let's see whether they are giving a biased, unbiased result or statistically significant result or not. Whether if the results are statistically significant, then the instruments are correct. Instruments are okay. Okay. So in the initial specification, just note that in the initial specification, I am using log of all the inputs as well as outputs, but the instruments are being used as in the labels, and that is the essence of the system GMM. Can you remember? The system GMM accommodates both the difference equation as well as, so if you are considering log, that means some difference is there. You are using difference value. Isn't it? Log means what? Difference value. dy dt. Log y is equal to log. If you differentiate log y, then it will give what? Dy 1 by y dt. Isn't it? So in this way, you are using difference equation as well as the equation in label, and this is the essence of system GMM. Okay, so copy this, in the instrument box. Now run the regression. Now you see that this is your regression result. Now you can see that the adjusted R square is very high, and Darwin-Watson is near about 1.19. So autocorrelation is also low. If it is near about 2, then it's better. But still, it is quite, but wow, greater than 1 is okay. Okay, and then you can look at the T statistics. The T statistics, you can see that log F fertilizer is highly significant. Manure is also significant. Area is significant. Total labor is also significant. I have also used a cross product term, that is the total labor square. Total labor square, it is also highly significant. So you can see the total labor is positive, whereas total labor square is negative. So first, with increase in total labor, output rises. Then after some threshold limit, with increase in total labor output falls. So that means it's an inverted U-shaped relationship. So total labor and output have got an inverted U relationship. First it increases, then it falls. isn't it? But they are statistically significant. Whereas you can only the seed, this input is only insignificant. Okay, the seed input is only insignificant. So you can go on using other proxies as well, and you can test your result. You can use your instrument, other instrument. You can also use the lagged value like the ad hoc approach. Okay, or you can use 2SLS method. Now this GMM method is giving a consistent result. So you can see that all the inputs are among the 5 inputs, 4 inputs are statistically significant, and they are giving some visual signs, and the adjusted R square is also very high. Okay, so in this way you can go on applying a generalized method of moments in your research.
Excuse me, ma'am. In the IV, do all the variable that we have taken, the same variable we need to take in the instrument list also?
Hello, can you repeat? Your sound is very much breaking.
Yeah, the IV that we have taken, all those we have to take in instrument list also.
Loudly, say loudly. Sorry, the sound is coming very low and breaking. Say loudly. Can you?
The variable that we have to take in the equation as well as in the instrument list. So all the variable we need to take in the instrument list also.
Anyone who can hear her, can you repeat the question? I don't know why the sound is breaking so much.
Ma'am, what she's asking is that do we need to take all the dependent variables in the instrument variables list?
No, not dependent variable. Don't take, because dependent variable is endogenous.
Oh, sorry. Those independent variables again in the instrument variable list.
Yes, actually we have not checked whether all the variable these explanatory independent inputs are explanatory variables like seeds, manure, these are endogenous in nature or not. That we have not checked here, isn't it? So we are actually, this is a single equation problem we are solving. If there are more than one equation, that means if you go on setting other equations as well, then you are taking the endogenous endogeneity in the model. That means we have not checked whether seed, fertilizers, all these variables are endogenous in nature or not. Okay, so we have to check it first. Then after testing for endogeneity, whether endogeneity is present or not, then we have to go for the instrument. It's a very interesting question that, but here, as we have already managed to take the level form as well as the difference form, and that is the essence of the system GMM. Okay, so system GMM can incorporate all the information of level as well as the difference. So when you are using the difference term, maybe in that case you are removing the endogeneity. So that is within the system, that the package is doing all the things. Okay, although it's a theory and the package is doing the generalized method of moment for the dynamic panel. Other name is dynamic panel model. Okay, it is well, you have already learned that the system GMM is helpful for running the regression on dynamic panel models, isn't it? So it's very much helpful for the dynamic panel models. And in this model, we have not checked whether where there is endogeneity problem or not. So you can check it first, then you can go for the GMM or the 2SLS or whatever you want. But system, I'm just trying to teach you how to run a system GMM with the help of the data in the EViews, with the help of the EViews software, EViews package, how to run system GMM. Okay.
Yes, ma'am. And I have another question.
Yes, and in the while discussing the system GMM, we've already learned that system GMM uses information of both the level as well as the difference models, isn't it? And that we have already shown here. That is, when we have considered the model itself, we have considered it in difference. That is the first difference. But when we have considered the instrument, that is the level form. So both the level as well as the difference form are being used. Different conditions are being used in the system GMM. Okay. Now, whether there is which explanatory variable is endogenous or not, For that, you have to check for endogeneity. You can go on the finding out the correlation between the error term and that explanatory variable, and you can that is the best method. That is the most simple method, isn't it? Find out the correlation. You can find out between the two series. You can find out the correlation. Isn't it? You have data on y, you have data on x, x1, x2, x3. You can find out y hat after estimation of y hat. You can have u hat, and you can check whether u hat and x1 or x2 or x3 are correlated or not. If there is some correlation, you can go for instrument. Either you can use 2SLS. You have seen that while going for the 2S estimation method, we have also seen 2SLS there. No, can you see 2SLS? A two-stage least square is also there. Okay, the same method. First, you have to enter the data from the Excel file. If it's in the Excel file, then it's much better to copy and paste in the view sheet. Then you can either use 2SLS or the generalized method of moments or dynamic panel data method to find out the instrument. So you have to use. So in that way, suppose you are finding out x1 as the endogenous variable, so you have to find out the instrument for that. Either you can use logic or you can use some other research where that they have also used, and it is giving some significant results. So I can also use the proxy for this variable. Suppose income suppose wealth variable. You are running a consumption function. You are running a consumption function model. Okay, consumption model. So C is a function of wealth. So you know that wealth variable, you don't have data on wealth. So sometimes it's very difficult to measure. So you can use some other proxies like income as the proxy for wealth. So proxy depends on your choice. That means which suppose you are using 2SLS or GMM, that depends on you. Okay, so I've just randomly selected some instruments, and I don't know that which explanatory variables are endogenous or not. That I have not checked. I'm just showing you that how to run a system GMM model. Okay, have you understood my point?
Yes, ma'am. So, what is advised, like before running this? What all steps we should take in general?
Yes, first we have to check the endogeneity. Whether endogeneity is present or not. Then you have to go for the method. Then instead of ad hoc solution, always go for IV, instrument variable, and either you can use two-stage score to find out the instrument and the estimation, or you can use the generalized method of moment to find out the instrument and the estimation of the model.
Yeah, it is that it is a combination of TSLS and maximum likelihood. So, if we go for TSLS and then maximum likelihood, and if we run the system GMM separately, both of them will give same result.
Can you repeat? I can't hear you. Actually, sorry, I'm so sorry. I can't hear you. Anybody can repeat her question?
You can write the question in chat box so that Madam can see.
Hello?
Yes, yes. Okay.
I can't remember. I can't understand her question. I can't hear actually. I'm really sorry. Can you repeat?
Writing the question in chat box. So let us find.
Okay. Chat box. Okay, that will do.
There are some other questions also in chat box.
Yes. Some other questions. So, how to check the chat box? Yes, 6 questions. Okay, let me first close this. Okay.
Excuse me, ma'am. In the meantime, would you kindly clarify that one GMM weights in the EViews, ma'am?
First, let me close this reviews. It will better. Ma'am, is there any way to identify? Okay, first let me. Good afternoon, everybody. Okay, good afternoon. Ma'am, is there any way to identify those through some tests whether there exists an endogeneity in my model? Yes. As I told you, okay, I have already discussed that you can find out the correlation between the error term and the explanatory variables to check the endogeneity. This is the first step. Okay, or you can also run a regression. Okay, if you If you're running regression, that means if you have a model of y on x, then you can, if you are suspecting x to be endogenous, you also run the reverse regression, x on y. Okay, so that will also do. So first step, find out the correlation or the covariance between the error term and explanatory variable, then you can run the reverse regression as well. Okay. Ma'am, please clarify GMM weights in views. Okay, GMM weights is basically the cross section sure that we have given. Okay, the GMM weight, that means to correct the autocorrelation problem if any in the data. You know that in panel data is basically a combination of cross section data and time series data. And in time series data, the autocorrelation problem is very prominent. And in the cross-section data, heteroscedasticity problem is very prominent. So as panel data is a combination of cross-section and time series, so both the autocorrelation problem or heteroscedasticity problem may be present. So to get rid of this, what we are doing is that we are using white cross section. That means we are cleaning the data from autocorrelation as well as heteroscedasticity. Okay. Is it okay? GMM weights, Nirmal Kumar Singh has asked. Is it okay? Can I go to the next question?
Yes, ma'am. Thank you, ma'am.
Okay, thank you. Next question is clarify GMM. Do we need to use log? Need to take log? Do we need to take log of all the variables to run different GMM? Yes, it's better to take log of all the variables. That means in the usual regression model as well, if we consider log of the variables instead of the original variable, that means the variables in level form, if you use the log of the variables, it will be better, because in that case you can use your parameters, use your coefficients to be the elasticity value. Isn't it the sensitivity? Isn't it? That means if you use, instead of y is equal to alpha plus beta x plus u, if you use log y is equal to alpha prime plus beta prime log x plus vi, then it will better, because in that case you can use beta hat prime to be the sensitivity of x to y. That means sensitivity of y due to 1 unit change in x. That means the elasticity concept may be used. Okay, so instead of taking the usual value, you can take the log. So same is the case in case of GMM as well, right? Ma'am, if we have negative values, how to take log? No, in that case you cannot take log. You have to correct the data. If you have to manage your data some way, that means negative values are not generally correct. Maybe you are doing some mistake, or you are having some problem in your data set. Just take it. Just use your logic. That in economics we don't have negative data, isn't it? So maybe growth rate or something else is there which can come out as negative, but the original data can never be negative. So you can use log value of the original data and you can run your regression. Suppose the growth rate is negative and you are taking the log. So that will actually talk about the acceleration. So you don't have to, and that will actually give you zero, the value 0, and your regression will be meaningless. So no need of, if you have any negative value, no need of taking the data set. You have to recheck the data. And you have to clean it first by using your logic, then you can run the regression. Bank return on asset, which is negative median. Yes. In that case, you cannot take log. Then you take the usual method. Okay, then you can also use the log values as instrument. If you are just omit that particular variable, and you can consider the other variables by using log. In that way, you can tackle you can manage your situation. And you see that actually, that research is basically a trial and error method. No method is exact. We cannot say that, yes, this method is, my method is exact, and his method is not right. So it's not like that. You have to go on trial and error method. You have to check whether your result matches with the real life situation, whether results can be logically or intuitively reasoned or not, it can be explained or not, that you have to check. That is your dependent variable. Oh my God. So you can go for 2SLS, I think, or you check without taking the log data. Dependent variable, that is basically good. That if you take the log value, if you don't take the log value, it's not a problem, because in that case you are running the level regression, and for the instrumental variable you're using the log of the explanatory variables. So your explanatory variable is positive, that's not an issue. Your dependent may be negative, and don't take in don't take the log model, you take the level model as the original one, and you take the log of the independent variables as the instrument. Okay. Okay, thank you. The next question is, can we use in bank data case median proportionate values? Medians are generally, we take the mean values or something like that. If you have a low number of observations, in that case we generally take median values. Okay. As I told you, you can see, if your mean value is not giving the exact result, maybe your data set has got some issues, so you can go on for median values as well. You can try it. Okay, you can check your result. You need to say that it is a combination of TSLS and MLE. Which is a combination of TSLS and MLE. I have one more query, that if we have variables which include some binary with 0, 1 nature, then run them together with other. Yes, why not? Can GMM be used for short and long panel as well? Yes. Are there any observations restrictions? No, nothing like that. You can use that data set as well. Okay, thank you. Thank you all. I think that I have managed to clear doubts, or your all doubts. Okay, and if you have any further query, you can mail me. I have given the email address. It is with your Digjoti sir as well. Okay, and in the first slide also there is my email ID. You can chondrimaeco@gmail.com. Okay, you can write your issues as well there. There as well, I can write the answer. I will try to answer your queries. Thank you all.
Any more
Thank
queries?
you, ma'am.
Okay, thank you.
Number of questions came and queries came, and it is evident, like from your deliberation, madam, it was a wonderful one.
Okay, yes, that's true, very true. If there are more questions, that means they have thought a little bit, isn't it? In these 2 hours, although it's laborious, isn't it? That means in these 2 hours, so many concepts has been, and I have tried to address as simple as possible, and so they have tried to think in this time, in this due time. So I'm very much thankful to all of you, and you have a patient hearing. Thank you all.
Thanks to you also, madam, like spending
you,
a
ma'am.
valuable time and giving us some session in this FDP. Thank you. I would
Okay.
request Fatima ji to do the honor of vote of thanks.
Yes, sir. Thank you, sir. I feel privileged and honored to have the opportunity to express a vote of thanks on this important occasion. I, Fatima Zahra, session coordinator of date 10, session 19 of this online 2-week faculty development program on research methodology and applied econometrics for social sciences, organized by Department of Business Administration, Assam University, in collaboration with Vidyasagar University, West Bengal, would like to extend my sincere gratitude to Assistant Professor Dr. Chandrama Chakraborty, our esteemed resource person, for our excellent discussion on critical elements of research on the topics that ma'am covered today, like problems of endogeneity, sources of endogeneity, consequences of endogeneity, solution to correcting endogeneity, IV estimation, 2SLS, remedy for endogeneity, endogenous and exogenous variables, method of movement, GMM system, and system GMM, to name a few. My sincere gratitude to Dr. Deepjyoti Chaudhary, sir, the convener, and the co-conveners, Dr. Shravanti Maiti, ma'am, and Dr. Taraknath Sahu, sir, for organizing such an educational session. The Department of Business Administration at Assam University in Silchar and the organizing committee in Vidyasagar University in West Bengal worked hard to make this event possible. It simply wouldn't have happened overnight. I would want to express my appreciation to all of the backhand coordinators for their continuous help in making the program work successfully. I would also like to thank each and every participant from India and abroad, without whose help the program could not have been carried out. We appreciate your efforts in making this event a success. Once again, I'm grateful to you, ma'am. Thank you.
Thank you so much.
Thank you, madam. And
Okay.
we would like to
Thank
hear from you again in future.
Thank you so much.
Thank you, madam. So we are ending this session here, and participants will meet again at 6:30 for the second session. Thank you.
Okay. Bye. Bye all.
Bye, ma'am.
Bye.
So, very good evening to all of you. It's my pleasure to welcome you all in the second session of 10th day uh, of 2 weeks FDP program on research methodology. In this session, we have Dr. Siddhartha Chattopadhyay, Assistant Professor, Department of Humanities and Social Science, IIT Kharagpur. Have a vast experience. He has a vast experience in the field of say applied econometrics and allied areas. So today he will discuss about the panel data analysis, how you can apply panel data analysis in your research work. He will discuss in the next 2 hours. So without wasting any further time, I request Joyita to please introduce our resource persons, Professor Siddhartha Chattopadhyay. Joyita.
Thank you, sir. A very good evening and warm welcome to one and all present here. I, Jaita Boro, a part of this 2-week-long FDB program, wishing all the professors and dignitaries present here a very belated Happy Teachers' Day. As we have been celebrating the Teachers' Day throughout this FDB session, so now I would like to dedicate today's session to MC Mary Kom. So MC Mary Kom, Mangte Chuchangjeng Mary Kom, was born in 24 November 1982, and she is an Indian amateur boxer, politician, and incumbent member of Parliament, Rajya Sabha. She is only woman to win the World Amateur Boxing Championships 6 times, the only female boxer to have won a medal in each one of the first seven World Championships, and the only boxer to win 8 World Championship medal. She has also ranked as the world #1 female light flyweight by the International Boxing Association. She became the first Indian female boxer to win a gold medal in the Asian Games in 2014 at Incheon, South Korea, and is the first Indian female boxer to win gold at the 2018 Commonwealth Games. She is also the only boxer to become the Asian Amateur Boxing Championship for a record 6 times and won 51 kilogram gold in the President Cup in Indonesia. Uh, on 25th April 2016, the President of India nominated Mary Kom as a member of Rajya Sabha, the upper house of the Indian Parliament. In March 2017, the Ministry of Youth Affairs and the Sports Government of India appointed her, along with Akhil Kumar, as National Observers of Boxing. So, as she is a role model for all the youths, so we wish her all the very best for the forthcoming years. So she is the personality with whom we like to admire every time. So now I would